We'll continue with the next subtopic, which is the energy. The energy ataupun tenaga. Okay, the energy of a body is a measure of capacity which the body has to do. Keupayaan untuk melakukan pelbagai kerja. When a force does work on a body, it changes the energy of the body. Energy can exist in a number of different forms, but we shall consider two types, kinetic energy and potential energy. So dia kata, when a force does work on a body, it changes the energy of the body. You still remember, masa sekolah dulu ada belajar hukum keabadian tenaga, kan? Hukum keabadian tenaga kata, tenaga itu tidak boleh dicipta atau dimusnahkan, tetapi boleh berubah bentuk. Maksudnya, ada banyak contoh tenaga. Okay? Kita ada tenaga Hubble, tenaga cahaya, tenaga kinetik, tenaga keupayaan. Okay? So, ada banyak bentuk tenaga. So, energy can exist in a number of different forms. So, dia boleh berubah dalam pelbagai bentuk. Contoh, if let's say saya kata, okay, katalah contoh ya, kita gosokkan kedua-dua belah tangan. Okay? Apabila kedua-dua belah tangan digosok, akan berlaku tenaga kinetik. Tenaga kinetik ni because ada motion. Okay? Ada motion, ada pergerakan. Jadi, tenaga kinetik pada permukaan tangan akan berubah kepada tenaga haba, menyebabkan tangan tu panas. Jadi, ada pelbagai bentuk tenaga. Tapi kita akan cuma consider two types of energy in this course, which are the kinetic energy and potential energy. Maksudnya tenaga kinetik dan juga tenaga keupayaan. We look at kinetic energy. The kinetic energy of a body is that energy which is possessed by virtue of its motion. So maksudnya bila ada pergerakan, maka ada kinetic energy. Dan bila ada pergerakan, normally dia mesti ada speed. So speed ni sama ada it can be a constant speed or the speed may change. It will have different speed. Initial speed lain and then the final speed lain. Okay, so you have to consider dia bentuk macam mana kinetic energy. Or in generally, it is the amount of work you need to work into an object or apply to an object to get it from rest to its current velocity. We know that work is the force times the distance as meter, where F is equal to ma. F is equal to ma by using Newton's second law. How can we find A? If let's say there is a motion, that means we will have a speed, velocity. And for the kinetic energy, it is starting from rest. So when rest means your U is equal to 0. So your A would be V squared divided by 2S. If we substitute our A here, then multiply with S. So we will get 1 over 2 mv squared. So this is the formula for kinetic energy. I have explained the relationship between kinetic energy and work earlier in the previous video, where the work is the energy transferred by the force. So we will use this formula, kinetic energy, if let's say you have a velocity or you have a speed. Okay, let's look at example 5. Find the kinetic energy of a particle of mass 250 g moving with the speed of 4 square root 2 meters per second. So the kinetic energy is equal to half mv squared. Mass will always be in kilogram. Okay, v squared. So this is equal to 4G. So the kinetic energy is 4 joules. Okay, and then we have potential energy. Potential energy of a body is the energy is processed by virtue of its position. Just now, kinetic energy, let's say you have motion, ada pergerakan, but potential energy is because of the position, kedudukan. Okay, contoh, if let's say objek tu diletakkan di atas. Okay, atas almari kita contoh, di atas almari. So, bila dijatuhkan, bila ditolak, dia akan jatuh because of the gravity. Okay, dan kemudian dia ada energy. Maksudnya without kita baling pun dia tetap akan jatuh. So we have the potential energy di dalam objek tu. Pada objek tu lah. Dan juga potential energy ini akan berubah bila dia berdasarkan dia punya position. Okay, apa yang diterangkan kat sini, when a body of mass m kilogram is raised vertically at distance h meter, the work done against gravity is mgh joules. So if let's say potential energy, kita gunakan formula mgh. Okay, the work done against gravity is a measure of the increase in the potential energy of the body. Okay, the body to do work is increased. If let's say it is lowered, then it is decreased. Maksudnya, kalau katakan satu objek yang sama, katakan this one kita ada dengan height 5 dan juga 3 objek. So, potential energy untuk, katalah this one is potential energy 1, this is potential energy 2. Okay, di mana objek yang mempunyai potential energy yang lagi besar? Okay. Bila yang lagi besar, maksudnya dia mestinya lebih atas lah. Lebih tinggi. Lebih tinggi, so potential energy dia adalah lebih tinggi. So ini apa yang dimaksudkan dalam paragraf ni lah. There is no zero of potential energy, although an arbitrary level may be used for which changes in the potential energy of the body may be measured. If let's say the object pada kedudukan yang static, maka dia tak ada potential energy. Biasanya dia dekat sini lah. Kalau if let's say objek tu dekat bawah, kat ground ke apa, so we don't have any potential energy. Saya akan tunjuk dalam next example. Kita tengok example 6 first. Find the change in the potential energy of a child of mass 48 kg when ascending the vertical distance of 2m. So senang je. If let's say motion tu bergerak ke arah ke kanan ke kiri, mungkin kita ada kinetic energy. Okay. Potential energy hanya untuk vertical sahaja. Okay. Maksudnya bila ada height, then we have a potential energy. Ya, kalau tak ada height, maksudnya dia bergerak horizontally, so we have a kinetic energy. And we don't have any potential energy. Okay, question number 6. Find the potential energy. So for potential energy, we will use mgh, 489, 9.81, and then the height will be same potential energy is by using mh 48.81. So what is the difference here? Because the question is change. Actually, let's say change means that the potential energy is gained. This one, potential energy will be lost. Okay, it lost the potential energy. Apa yang dimasukkan ni, kalau katakan satu child 48 kilogram, kemudian dia berubah kedudukan dia. Tinggi 2 meter. Lepas tu dia duduk kat sini. So, potential energy dia bertambah sebab dia kedudukan dia lagi atas. Macam saya mention tadi lah, kalau misalnya potential position dia di atas, dia lagi tinggi dia punya potential energy. Kemudian yang ke B, kalau misalnya pada kedudukan yang ni, lepas tu dia turun kedudukan dia ke 2 meter, lepas tu dia duduk kat sini. So, potential energy dia makin berkurang. We look at example 7. A cricket ball of mass 400 G moving at 3 meter per second and a golf ball of mass 100 G have equal kinetic energy. Find the speed at which the golf ball is moving. Untuk soalan ni, okay, this is kinetic energy. So if let's say kinetic energy, we have mv squared. So half. Okay, this is for the cricket ball. I put a C here. The mass must be in kilogram. 3 square. So this one you get 8.1 joules. Okay, and then the kinetic for golf is half mv square. Half m is 0.1. V, you're going to find V, and it has the same kinetic energy. So straight away, V is equal to, you will get 36. So V is plus minus 6. But the question is speed. So if let's say speed it is a scalar. So if let's say scalar, you don't have to have a negative or positive direction. If let's say positive negative is to determine the direction. Tapi kalau speed dia scalar, so ambil je lah positive dia, which is the speed is 4 meter per second. And then for question number 8, the body of mass 4 kilogram decreases its kinetic energy by 32 joules if initially it has a speed of 5 meter per second. Find its final speed. Okay, so kalau misalnya initial kinetic speed, kinetic energy is half mv square. So half for if initially has a 5 square, so 25 30 joules, and then final, and it decrease its kinetic energy by 30. Sini 50. Dia kinetic energy by 32. So final decrease by 32. So you get 18 joules. So the question is final KE. Final KE is half mv square. So half, mass tak akan berubah kan? So v square, the question asks to find the speed. So v square is equal to 3 meter per second square. So this is the final